Hey guys, this video is about another new concept that we're going to talk about that you've probably heard before, and this is going to be called potential energy. So let's write that up here real big first. Potential energy. So I'm sure you've heard this word potential before, and that just means having the capacity for. So you have the potential to be a great athlete, or you have the potential to be a rocket scientist. It means you have the capacity to do that. So we're saying potential energy, having capacity or holding energy. So we go, well, what's this thing energy? We haven't talked about it yet. So let's try to relate to something we do know. And we just talked about this concept of work. You know, you get hired for a job. Your job is to move bricks. So you might say, you know, I would need energy in order to do my job. I couldn't go to work at 8 a.m. and be exhausted and then move bricks all day. I wouldn't be able to do it. I'd have to have a good night's sleep, eat breakfast, etc., etc. So we can define potential energy really simply as saying potential energy means the ability to do work. It's a very simple definition, but that's what we're going to use for now. Now, you can have potential energy a lot of different ways. We're going to focus on gravitational potential energy. So I'm just going to write that here for the most part. Gravitational potential energy. But there's a lot of ways that you can have the ability to do work. Now remember, work just means apply a force over a distance, or like move an object a distance by pushing it. So, for instance, a rocket that is full of fuel has a lot of potential energy because it could push itself up. A loaded gun has a lot of potential energy because it can push the bullet over. But there's other ways to think about potential energy. Here's a really simple one. Imagine if you're in a room and there's a big bookshelf and there's two bowling balls. One bowling ball is on the floor and another bowling ball is up precariously sitting at the top of this bookshelf. Well, this bowling ball probably doesn't make you too nervous, but that bowling ball might. You know, the bowling ball that's on the floor isn't going to go anywhere. We're not worried about that. The floor is flat, it's not going anywhere. But that one hanging up on the bookshelf, if we just kind of shook the bookshelf a little bit, it might fall down. Right? So there'd be a force of being applied, gravity, and it would travel a distance. So work would be done. In this case, it would be gravity doing the work. Now, that might not happen, but it has the potential to happen. So we could say that this ball has potential energy. And we could say exactly how much. Because if it was this high off the ground, let's call that D, and we know how hard gravity pulls, we could say, oh, I know exactly how much work it would do if it were to do the work. So I know how much energy it has stored because I know its capacity. Now, because we're running out of letters, we're going to use the letter U, capital U, for potential energy. And for gravitational potential energy, little UG, it's equal to Fg times distance. Or in this case, you know, D is not really such a great letter because we're not really talking about distance. We're always going to be talking about a height when it has to do with gravity. So let's replace these. Instead of calling that D, let's call it H. Instead of calling this D, let's call it H. Well, and you know, Fg is nice, but really you have to break it down another level. So really, potential energy from gravity is equal to mass times Ag times height. And again, since potential energy is an energy, it's just like work, we're going to measure it in joules. So let's say this is a 5 kilogram bowling ball hanging out 3 meters above the ground. How much potential energy would it have? Well, very easy. Ug equals mass, which is 5, times Ag, which is 9.8, negative 9.8, and then height, which is 3. So you end up with about 15 times about 10. So somewhere around 150 joules, I'll put approximately. Now you might notice something. There's a negative sign there, and there's not a negative sign there. Right. Energy is a scalar. It doesn't have a direction. Even though this bowling ball would fall down, its energy doesn't have a direction. A better way to think of potential energy might be the rocket. A rocket sitting on the launch pad has lots and lots of potential energy in the form of fuel. But that fuel doesn't have inherent direction to it. That rocket can go up just as easily as it could go over if we pointed it that way. So energy is a scalar. It does not have a direction. And since we've been using negative signs to indicate direction, you have to be aware that when you're solving for something that's a scalar, that negative sign might just end up coming out. Right. That's it for now. Bye now.